All right, calculus. I cannot believe we're still on 7.3. I am horrible. I apologize. So let's do some of these. If you've already figured this stuff out, awesome. If not, I am not terribly surprised because it's really not that difficult once you understand how to do it, but it makes absolutely no sense until someone explains it to you. At least I think. Maybe you got it from the book, but here we go. So this whole section is about transforming things, okay? And it's all about using those same identities, mainly this guy up here, or which one is it? It's the cosine squared of x. That's weird. That's not what I'm thinking. Cosine squared of x plus sine squared of x equals 1. It's these guys, the Pythagorean properties. So cosine squared of x plus sine squared of x equals 1. 1 plus tangent squared of x equals... So it's all about using these three identities and this stuff. Okay, that's this whole section. It's really just about converting the things into what you want to get it the way you want to get it. Okay, so let me show some of these problems. Let's start with this first guy. We want to transform sine of x, cotangent x, into cosine of x. Okay? All right, so these are full-on proofs, guys. So there's some methods to kind of work with proofs that help a little bit. Sorry, the lighting is terrible here. I'm at my grandma's house. We're keeping her company. So we got sine of x cotangent of x is equal to cosine of x. Okay, so when you're doing proofs, usually you'll set it up like this. They call them two-column proofs because you will be adjusting this column, and this column essentially stays the same. You just want to keep doing things to this side until it equals that. Okay? All right, so the first thing I'm going to do was I'm going to turn this cotangent into something else. Sine I can't really say anything with, but cotangent I know stands for something else. So sine of x, so if, again, I look at my properties, what does cotangent stand for? Well, I know that tangent is equal to sine of x over cosine of x, right? And cotangent is the reciprocal. So that means cotangent is equal to cosine of x over sine of x. Okay, so I'm going to replace cotangent with this. So I'm going to say cotangent is now cosine of x over sine of x. Okay, so look, hopefully you're like, oh, okay, and yeah, that's really how these are. There will be a point where it's like, oh, okay, and it just kind of clicks, which is one of the reasons I actually kind of like proofs, at least these kind of proofs. So now we've got sine, and they're multiplying, so those go away, and you're left with cosine of x equals cosine of x. You're done. That is the whole problem. Okay? So again, these are pretty easy once you understand what they're asking you to do. Okay, let's do another one of these. All right, I'm going to look at the second one. The second one is asking us to transform cosine squared of x minus sine squared of x. We want to turn that into 1 minus 2 sine squared of x. Okay. So I want to turn this guy into this guy. All right? So here's a nice little trick. If you ever see squareds, that's your clue that you're probably going to be using the Pythagorean property, which is the whole cosine squared of x plus sine squared of x equals 1. Okay? If you see cosine squared, sine squared at all, you're probably going to be using this formula. If you see cotangents, tangents, secants, cosecants, you're probably going to be using the fractions. Okay? Generally, most of these break into one of those two. All right. And so then you just kind of go and see what you can do. So let's see. So I want sines in the end. So that means I'm probably going to want to get rid of this cosine. Okay, so you know what? I'm going to take this and I'm going to write it so that it's cosine equals something. Okay? So I would have cosine squared of x equals 1 minus sine squared of x. Right? So cosine squared of x equals that. Yeah, you guys, that makes sense. Okay, so here's what I'm going to try. And honestly, a lot of this stuff is trial and error. Sometimes you'll try something and it'll work. You'll be like, cool, that worked. Or you'll be like, oh, that's not working. Let's try something else. Whatever. That is math. Like, seriously, once you get to past like high school math, this is math. All right, so I'm going to replace this cosine with this 1 minus. So I'm going to say 1 minus sine squared of x minus sine squared of x equals 1 minus 2 sine squared of x. Okay. Well, I've got my 1. I have minus sine squared of x minus sine squared of x. I have 2 of these. So I could rewrite this as 1 minus 2 sine squared of x. And I am done. That's it. So then you get to use that amazing QED, again, which is Latin for quantum erat demonstratum, something like that. I mean, it means it's true because of all what I just showed you. Kind of neat. Okay, there's 2 examples. How am I doing? I'm at 6.5 minutes. Look at this. Okay, where's example 3? There's example 3. Prove algebraically that, let's keep going. 1 plus cosine of x times 1 minus cosine of x is equal to sine squared of x. All right. So I want to prove that this is equal to this, that it is an identity. So when it asks you to prove that it's an identity, basically it's saying, show that you can change this into this. It's really just what you just did. It's just a different way of phrasing it. Okay, so we have 2 binomials. I'm going to FOIL. We're going to say this times that. 1, this times that. That's going to be minus cosine x. This times this, that's going to be plus cosine x. This times this, that's going to be minus cosine squared of x. Okay, and then we still have equals sine squared of x. Okay, well look, we have minus cosine plus cosine. Hey, those middle terms cancel out. So cross out, and we are left with 1 minus cosine squared of x equals sine squared of x. Is that true? Well, yeah, it pretty much is. If I had solved this at sine over here, it would be 1 minus sine squared of x. So we know that this is an identity. Sure, if I really wanted to, which honestly I can't remember if the book wants you to do this or not, I could add this to both sides, and I would get 1 equals sine squared of x plus cosine squared of x, which gives you the actual identity, right? That is the actual identity that they used. So, but yeah, that's it, and we're done. QED, finished. Okay, let's see, what do we got next? Let's keep going. Prove cotangent plus tangent. Here we go. I'm just going to keep going through these. I know I'm going really fast, but that's the beauty of me doing this now versus in the classroom, because this is here forever. You can always go back and look at it. You can rewind it. I'm going to do another video where I do some of the homework problems too, so don't freak out that I'm just tearing through these examples and needing me to do homework problems, but I just want to get you guys something. Okay, so example 4, we've got cotangent of A plus tangent of A equals cosecant of A times secant of A. Oof, that's a lot of stuff. All right, let's take a look at this stuff. Okay, so generally with these, you want to just work on one side of the equation and not the other. Because if you work on both, you can kind of write yourself into a hole real quick and get lost. So I'm just going to work at this cotangent and tangent side. Okay? So what I'm going to do is I'm going to break these cotangent and tangent like this. Okay? So I'm going to say this is cosine of x, or sorry, cosine of a over sine of a plus sine of a over cosine a. Okay? So there's a plus. I want to add them. So in order for me to add them, they need to have a common denominator. So the common denominator would be to multiply this side by cosine, right? So I'm going to multiply this side by cosine of a over cosine of a, and multiply this side by sine. Sine of a over sine of a. So I'm going to multiply this over here, this over here. That way they'll end up with a common denominator of cosine times sine of a. All right? So now let's write this all out. And we'll end up with cosine squared of a over cosine a sine a, right? Plus sine squared of a over cosine a sine a, right? Uh-oh, uh-oh. We have cosine squared and sine squared. Okay, and there's a plus. Oh crap, oh crap. So now, that means I can take this guy and write it like this. Cosine squared of a plus sine squared of a all over cosine a sine a. And this up here, we know is 1. I am running out of paper. We're just going to running out of paper, and I'm like stretching out. Here we go. We're just going to use the bottom of this paper. Okay, so we got cosine squared a plus sine squared a over cosine a sine a. Okay, so I can rewrite that as 1 over cosine a sine a. And I've kind of ignored that whole equals sign, so I'm going to bring that back. It was, where were we at? Equals cosecant and secant. Okay, so let's go back down here. And we wanted to get this equal to cosecant of a and sine of a. Okay, so what is cosecant? Nope, not sine. Secant. Well, cosecant and secant are just 1 over cosine and 1 over sine, which means I can write this as cosecant of a times secant of a equals cosecant of a secant of a. And I'm done. QED. Okay, so that one was a lot more. Let's scroll back through it. Okay, so we started out with this. Okay, I got common denominators, right? I multiplied this side by cosine over cosine, this side by sine over sine. All right, that gave me cosine squared and sine squared on the top, and I have my common denominator of cosine and sine. Okay, so when I combine them together, I have cosine squared plus sine squared. That is an identity. Cosine squared plus sine squared equals 1, which allows me to make this transformation. And so then I have 1 over cosine times 1 over sine. Well, 1 over cosine is secant. 1 over sine is cosecant, and I'm done. Okay? All right, let's do one more on these before we finish. We'll go down to example 5, and then I'm going to end this video, and I'll do some homework problems to hopefully get you acquainted to those. All right, so this problem, this is I think our last one, right? Example 5, yep, last one. I want to give you lots of procedures. Yeah. Okay, so we want to transform or prove algebraically 1 minus cosine of b over sine of b is equal to sine of b over cosine 1 plus cosine b. Okay, well, this looks gross because we have 1 minus cosine b, which looks kind of like the trig identity. But then we have sine down here, so it's a little messy. So let's think. So if I multiply it by something to maybe get that, what's it called? Think. The Pythagorean identity. So we have a squared on the top because we don't have a squared yet. So if I could multiply it by something to turn this into that Pythagorean identity we wanted, let's write it out over here. Just 1 equals cosine squared of b plus sine squared of b. Okay, so 1 equals, so I want to get it looking something like this, where I have a 1, but I have squares. Okay, so what I'm going to do, it's a little weird, and like I said, it takes some getting used to these tricks, which is why I'm working through all these with you. This gives you a good repertoire of these tricks. So I'm going to multiply this to turn that into one of them. So what I would do is multiply it by whatever. I'm going to multiply it by 1 plus cosine of b over 1 plus cosine of b. Okay, so now this will turn into my form kind of like this. Remember, it's just like the last one. So we end up with 1 times 1, we get positive 1. 1 times negative gives me a negative cosine b. This times this gives me a positive. So those cosines cancel out. So we have 1 minus cosine squared of b over, and then I have to distribute. So I end up with sine of b plus cosine of b. Oh, cosine sine of b, right? Because I have that sine of b distributed. It goes to the 1, it goes to the cosine. So we have 1 sine of b, or blah, blah, blah. Yeah. So this up here, now, I can rewrite. Because this, I know, is the same thing as sine squared. Okay? So this, just like over here, remember I can rewrite it? Let's do that. So we've got sine squared is equal to 1 minus cosine squared of b, right? So I know that this is equal to this because I just moved that b. I always forget the letters. So I can rewrite this now as sine squared of b, right? Over sine of b plus cosine b sine b. Uh-oh. Do you guys see what's happening? All right, time to factor. Okay, here we go. So sine squared of b is just sine of b times sine of b. So I'm going to write that. Sine of b times sine of b. Right? And then on the bottom, remember I distributed that sine of b? I'm going to undistribute. So now we've got sine of b, and remember it was times 1 plus cosine b. So this, when I divide it by sine of b, becomes 1. This gets rid of that sine b, and we end up with cosine b. And now look, that goes away, and I'm left with sine of b over 1 plus cosine b. What were we trying to get that to equal? Sine of b over 1 plus cosine of b. We did it. Okay, so that was a little tricky. 1 plus cosine of b. But hopefully you guys have seen, I believe those are all the tricks that you basically have to use in this section. Like I said, I don't know how many of you guys have already done this. It's a rough section because it's a lot of this. But once it clicks, it clicks, and it's pretty easy. So I'm going to sign off because I'm at 20 minutes already. I will probably do a video of this, some of the homework problems, and hopefully that'll help. All right, guys. Sorry for the delay. Hope that helps. Adios.